Hello there. My name is Eduardo Benavides, and this is my video slash audio recording presentation for Homework 5 in CSE 546. So pretty much what this is going to go over is the use of the k-means clustering algorithm being applied to our data set. So the data set that I'm talking about is data that includes 10,000 images that were extracted from the Safari-10 dataset. We have three files we're working with. The X file contains the features from the images. The Y file are the true labels, which is our ground truth that we will use later on. And those labels are plane, car, bird, horse, and ship. And the images file contains the pixels to create the images. So that's what we're going to be using the k-means clustering algorithm on. Just to show you that we got something working here, we'll load in the files. And then the first thing we have to do is find the optimal number of clusters. Now, in order to do so, I created the SSE versus number of clusters plot. And in finding the optimal number of clusters, we use the elbow method, or I used the elbow method. And in using the elbow method, I have learned that the knee locator library here from Need is very useful in using the knee method, which is similar to the elbow method. In using that method, we're essentially finding the point of the decreasing rate where it makes a sharp turn to where that decreasing rate becomes more consistent instead of a decreasing style. And according to this, that point is at 10. So the optimal number of clusters is 10 clusters. So we use that for the rest of the project, and in about 7 seconds, you will see the generated silhouette plot that I have constructed. Now, this shows the quality of the clusters. So we have 10 clusters, so we're going to see the quality of 10 of those 10 clusters. Now, what we can learn from the silhouette plot is mainly two things. Um, well, not really two things, just really one thing. And that one thing is how well are 10 clusters doing for this data? What's the prediction? That's what you learn from it. The prediction is average. The quality isn't the best. It definitely can be improved for sure. You can see there are some silhouettes that are more leaning towards one, but we do have a lot of silhouettes that are in the negatives and a lot that are close to zero as well. And with our average score being relatively close to zero, essentially, we're essentially saying that there is a mix of well-separated clusters, which there are, like cluster 3 and even cluster 2 and 9. There is a mix of well-separated clusters, but there are some clusters that will probably give questionable classifications. And that is because, due to that silhouette score right here, this average silhouette score being close to zero, it's telling us that not all of them are well separated and there's overlapping involved, most likely. We won't actually get to see that until the next part. And that next part is where we find five core samples, which that's going to be running for you. It's going to find five core samples of each cluster. So essentially the samples they're in there. They're properly assigned. And then it's going to find two boundary samples, if there are any. And those boundary samples are the ones we're going to be looking at because those are the samples that could be involved in the overlapping. So that's very important. Now we're going to move to the OneNote file because it's easier to look at all of them in here rather than me scrolling down through here and showing you. Um, so here's the OneNote file. And we'll kind of go through all of them quickly here. For cluster 1, it's all boats, it's all ships. Nothing misclassifying about this. That's a ship, so that's a boat. We're all good here. These are all birds. Birds. That looks like an ostrich to me. Just for some reason, its head is kind of very square, and that's just a small bird. You can tell from the shape. So this looks all good to me. Cluster 3 gives us our first misclassification as it's planes. I'm pretty sure this is a sailboat. That looks like a sail. And I'm confident it is that triangular shape in the sail that caused the misclassification, but also the overlapping that I discussed earlier is probably at play here. Thankfully, I wouldn't say this is too big of a misclassification. I mean, like I said, if it is really that triangular shape, I mean, then it's understandable. This, however, is not. This is a plane. I don't know how this looks like it's one of these. Like, even this look could be a plane with landing gear out, but let's just say, for the sake of it, it's a bird. This is a full-on plane. It's a fighter jet, essentially. All right. The only similarity it has with the birds is that it's flying. That's it. So overlapping, causing very questionable classifications right here. Cluster 5, they're all planes. We're all good there. Cluster 6, Cluster 7, all good there too. You got your cars, you got your horses. Cluster 8, we're going to go back to the code file for this one because you can see it's horses. It's hard to see, but this is a horse. You know, this is a horse, you can tell. At first glance, I had no idea what this was. It wasn't until I put it in the OneNote file and shrunk it that I saw, this is a plane. Apologies for that. This is a plane. All right. Again, I think the only understandable reasoning to why it is in this cluster is because it was at least difficult for me to see what it was enlarged. But I don't see how that would cause any confusion other than the fact that there's overlapping happening, probably. So that's a misclassification. These are all ships. We're all good here. That's cargo. And this is very understandable, actually. This is a boat, not a car, as you can tell, but it's at the exact same angle as that one and that one, so it's understandable. And also, it looks like it's a boat being towed by a car from a family that's probably going to go to their house on the lake. So it has the land part right in the wheels, which is probably somehow seen, but that is a boat that needs to be with the ships, not the cars. So overall, this is just telling me that based off the core samples and the boundary samples, we are classifying things properly. But as you saw, we are having some questionable classifications, some misclassifications that are not understandable whatsoever, like that plane with the horses. And the last part is we calculated the ARI score for each for the number of clusters, which is 10 for our optimal number of clusters here. And it's at around 50%. So what that tells me is that it's pretty moderate. It's better than random, it's more meaningful. It's able to kind of read the structure of the data and able to make the proper clusters it needs, the proper classifications it needs, while still having a lot of room for improvement. This definitely could be a higher score while making better classifications. Um, so yeah, all that tells us is it kind of confirms the prediction we made from the silhouette plot, where this is a very average result that we're going to get, where we have a lot of room for improvement. Now, this could be perfectly fine for some people with that score. For them, this could be perfectly okay. For me personally, I would like to see the score a little bit higher. I would like for the algorithm to be able to make much better classifications than the questionable ones we saw earlier. So, is 10 the optimal number of clusters for this data set? Maybe not, might be 8, but it doesn't do a bad job. And that is my conclusion for this homework. So that is all I have to say. Thank you so much for watching. Peace.